Hello. Thank you for taking the time to check out our senior project. We are Team 24, designed for additive manufacturing, and we're very excited to share the results of our project with you. Our team is comprised of 4 undergraduate mechanical engineering students: Sam Noble, myself, JP Purdom, Michael Sharonay, and Leo Franco Munoz.
Our sponsor is none other than Solar Turbines Incorporated, headquartered in San Diego, California. They are a wholly owned subsidiary of Caterpillar Incorporated, and they're a leading provider of energy solutions. Solar Turbines would like us to redesign 2 existing cast components to be 3D printed in metal. Each of these parts has its own needs and challenges that must be addressed to ensure effective printing.
So going into the little bit of the background of additive manufacturing. Additive manufacturing, specifically for metal printing, produces the 3D metal parts by using a layer by layer approach. And the machine will lay down a single layer of powder and then use a laser to melt that metal powder, and then it will slowly build up the layers. And this approach enables the manufacturer to manufacture very unique geometries, and also allows for more quick prototyping abilities, for weight reduction, for reduction in lead time, and ultimately reduction in manufacturing costs. So going into the results of our first part, the bracket. For this part, our main focus was to decrease the weight of the part. And we did this, as you can see in the middle picture on this slide, by hollowing out sections of the bracket arms. And we also decreased weight, as you can see in the left picture on this slide, by adding in a lattice structure to the main cylindrical portion of the bracket. And ultimately, we were able to print this design, as you can see in the picture on the top right, complete with the lattice and the hollowed bracket structures, and we're able to significantly decrease the weight of the part.
The thin plate part presented us with a more unique challenge because it was thin. When printing a thin part, these parts are more susceptible to distortion and warpage due to their heating and cooling, which can cause this warpage and distortion, as you can see from the simulation result in the top right. Our goal for this part was to be able to compare a physical print with a software prediction. However, due to COVID-19, we were not able to compare these two. We ended up pivoting our project more to a software-focused approach. Our goal for Solar Turbines was to give them a software recommendation by comparing a few different softwares and seeing how they performed with their simulation packages.
We'd like to thank Professor Schuster, our advisor, Dr. Wang from the IME department, and the Cal Poly Mechanical Engineering department for supporting us with our project. And thank you all for watching. We appreciate the support.